Hi everyone, my name is Yulin Zhang, and the topic of my presentation is about concentration, a context-aware browser-based system to enable distraction-free focus mode using AI and natural language processing. Concentration is a Chrome extension that I developed during the past 2 years, and Dr. Zhang has offered me a lot of valuable advice. The problem that concentration aims to address is the increasing degree of online distractions. Nowadays, with the advent and prevalence of electronic devices, many people with online access find it increasingly difficult to concentrate while working in digital environments. Be it social media notifications or updates from frequently visited websites, the constantly changing internet makes it tempting for one to access irrelevant websites and continue to browse it for an extended period of time while working digitally. According to a study done in Statista, people around the world spent an average of 147 minutes per day on social media in 2022. In the long term, constant online distraction could cause procrastination issues, shorter attention span, and even decreased productivity. Therefore, I want to take an innovative approach to combat digital distractions and improve work efficiency for everyone that is facing such difficulties. The initial idea I have in mind is in alignment with my final implementation. I believe that concentration is best implemented as a Chrome extension due to various reasons. It is free to download and use. It is available to everyone, and by that I mean people can just go to the web store and download it. And for this reason, it could gain popularity easily. I also imagine concentration to work like a website blocker that takes keywords from the user and auto-blocks websites based on these keywords. For example, if the user hopes to block gaming websites, they could enter the keyword game or gaming, and concentration should be able to figure out whether every website that the user visits is related to gaming. If they are indeed related, concentration would block the website right away. In other words, the keyword represents the categories of website that the user wants to block after enabling the extension. Beyond these functionalities, I also plan to implement a parental control system that gives parent users more control over their children's accounts. This is still a work in progress that will be released in the future. So the approach I take consists of web scraping and text summarization. First, the user will enter keywords into the extension. As I said earlier, these keywords represent categories of websites that they want to block. After entering the keywords and enabling the extension, concentration will come in play whenever the user visits a new website. For every website that the user visits, the funnel of concentration will obtain the website content and pass both the contents and the keywords back to the backend. After receiving this data, the backend will use a natural language processing algorithm to summarize the web content. The backend will then compare the summary to the keywords to calculate a similarity score and checks to see if the score exceeds a small threshold value. If the score does meet the threshold, the backend will let the front end to block the website. Otherwise, concentration will not block the website. So all of these functionalities or procedures are implemented in concentration. During this blocking process, various algorithms and common techniques are employed. For example, the front end uses web scraping to obtain the textual website content for every website that the user visits. Furthermore, the backend uses the PageRank and cosine similarity algorithm to summarize the website contents it receives into several short paragraphs. The front end and backend also uses network requests to transfer data back and forth between them. Finally, if the backend determines that the website should be blocked, the front end uses basic JavaScript code to manipulate the DOM or document object model in order to block the website. Some challenges that I have encountered over the course of development are finding an accurate summarization algorithm, designing a clean and usable user interface, and keeping up with extension standard. For the algorithm part, I have tested multiple algorithms' performance, including the TF-IDF or term frequency inverse document frequency algorithm, the text rank algorithm, and the combination of page rank and cosine similarity algorithm, which was proven to be the best and most accurate algorithm out of all the algorithms tested. Furthermore, it's quite difficult to design a clean and easy to navigate user interface in confined space. And for this reason, I have actually consulted my friends who have experience in graphic design for their advice. It's also challenging to migrate from Manifest version 2 to version 3, which is the latest standard for all Chrome extensions, due to the lack of documentation and online discussions. So there are 3 features that makes concentration stand out from other similar implementations. The first one is flexibility. The types of website that concentration blocks entirely depend on the website. On the keywords that the user previously entered. The second one is intelligence. Concentration uses web scraping to obtain the web content and natural language processing to summarize the content, and both processes are fully automatic. Concentration also uses more modern algorithms in the program, namely the PageRank and cosine similarity algorithm. So here's a video demo on using concentration to block gaming website. In this short video, you'll see me entering the keyword gaming into the extension and then accessing a gaming website and an education website after having the extension enabled. So as you can see, concentration blocks the gaming website, but not the education website, which is not relevant to the keyword gaming. The backend of concentration is implemented using the Flask, iGraph, NumPy, and NLTK libraries. The Flask library is used to set up the backend server that accepts incoming requests from the front end and sends information on whether to block the website to the front end. The iGraph, NumPy, and NLTK libraries are all used in the text summarization process. The picture on the right shows the cosine similarity function that takes 2 sentences and returns their cosine similarity. In the front-end part of the extension, JavaScript, HTML, and CSS are used to support user interactions and construct user interfaces. While JavaScript code is mainly used to deal with user input and blocked website is needed, HTML and CSS are used to construct the pop-up page and the website of the parental system, which is still in progress. To test concentration's performance, we have conducted multiple trials at 5 different points in time. For each test, we first enable the extension, enter a keyword into the pop-up, and then access 2 irrelevant websites and 3 relevant websites. We then record whether concentration correctly blocked these websites in a data table. If the extension blocks an irrelevant website, the result will be a false positive. Conversely, if the extension does not block a relevant website, the result will be a false negative. On average, the accuracy of concentration is over 90%. Which is pretty accurate. In the past, there were some studies that were similar to our project. For example, there was one project that uses the MapReduce framework to summarize large text chunks. There was also an automated system that identifies and blocks inappropriate websites, and another system called SS Notes that analyzes and summarizes tags and user comments. Our project works on smaller web content and uses the summary to categorize the websites. For the future development of concentration, I plan to complete the parental control system to give parents user more control over their children's accounts. I will also consider other summarization algorithms to summarize web content. Thank you, and here's my email and the link to the GitHub repo. Any questions or comments?